Okay, we'll get started. Hello everyone, welcome to RubyConf 2021. Hi, I'm Chris Cha. I'm a full stack dev working in test automation and DevOps at the Container Store, which specializes in organizing solutions like custom closets and the joy of tidying up your space. Yes, we still use containers, but also cloud and orchestration technologies to define a scalable, highly available future. Join us. The title of my talk today is Automating Legacy Desktop Applications with JRuby and Sakuli. Here's an example of my development environment. I have Vim to edit text, Sakuli IDE to manage screenshots, X-Free RDP to remote into the Windows VM, and multiple terminals to run Vagrant and other chores. Within the Windows VM, I used command prompt to run individual tests with JRuby. Our goal is to automate a very battle-tested legacy application. To start, I couldn't just run Windows. I'm on a Mac. The app is Windows only. My go-to for VMs is VirtualBox. Vagrant provided an easy way to export from VirtualBox. I found a Windows 10 Pro image from Microsoft and made changes to help with remoting. If I could run JRuby with Sakuli, I could win. But it was all only imaginative strategy at this point. I guess my ambition was to learn Vim, Vagrant, Sakuli, and JRuby plus Java all at once and assumed it would integrate in the end. Here is the transform script. It takes every .ed file in transforms directory and applies it to the Vagrant file. I wanted to be able to start from scratch at any time, create a new folder, and be able to get to the current state. This forced me to keep changes isolated and, in retrospect, helped manage complexity. The Vagrant file would have otherwise been littered with commented half experiments and distraction over syntax. From previous attempts, I knew X-Free RDP would let me connect to Windows machines. I just needed to figure out how to do that with a Windows VM instead of a remote host. Fortunately, many other people had solved this problem. Our first transform looks for the line config.vm.network and appends content to it. It almost looks like a code block. RubyConf always reminds me to put a new line at the end, and it was important to do that with .ed files. From earlier research, I knew the app in question pulled in its own JDK. I just needed to bootstrap the app, and adopt OpenJDK had the easiest way to install. So we'll call this the is this even going to work step. If anything, at least I had a Vagrant file for a nice Windows VM, and JRuby needed Java. I could use command prompt to poke around inside the system. Here's the batch script we use to set up Java. We download, extract, set a path, and done. This is the usual route for most binaries. I avoid using a package manager for now, since I didn't want issues there to confound attempts, really liking the PowerShell to extend batch scripting capability. Since Vagrant prints things to console, we could invoke commands within the VM OS context and get useful results back. Here, we invoke Java and ask its version. This verifies the path is set. JRuby will know where to get its Java, and all will be well. More challenges await. My second transform is a sanity check, just to make sure .ps1 files work. So PowerShell will execute as well in case we need it later, but also a way to append to the end of the Vagrant file instead of the middle. We pretty much use this approach to add on the rest of the changes. Here is the transform to the Vagrant file to layer JDK installation on top. Every change, big or small, is run through a pattern of a transform and a script. Here, we just layer on the Java verification script, where we check the Java version. So we still need our app to test. It's not available from the VM. We have to retrieve it from somewhere. Our source is a mapped network drive, so we need to map a network drive. We figured out Java first, since that was easier, but now we dig further into Windows. We need an app to run. Interlude. It might be nice to share the Vagrant dev loop. We retrieve a public image, apply transforms, and then start it up with Vagrant. We reboot too, and then try to remote in with X-Free RDP. We now have a Java development environment, but it can become so much more. We need a strategy to map a network drive correctly every time. We can do this with a scheduled task. We use the XML version by exporting a basic task, because this is the only way to create a task with all conditions disabled. For example, on a laptop that is not plugged in, the scheduled task would not run, because it would detect the server, our machine, was on batteries. The crucial piece here is PowerShell supports here doc strings, so we can paste the XML directly. Here's the rest of the scheduled task XML and script. We create the scheduled task with PowerShell using the XML content. After Vagrant reload, we should have a mapped drive. All this to support one batch script, but a useful pattern for the future. There was more to it, I guess. We make sure to delete our temporary XML file. In order to map the drive, we need credentials. These can be collected at Vagrant build time as a user prompt. Now that we can acquire the app, we have to figure out how to run the darn thing. Each app is different and unique in its own way. In our case, the app uses Java Swing, multiple windows, and a separate launcher dialog. The app was distributed as a JNLP file. Opened as a text file, we could retrieve the startup arguments and try to reproduce it ourselves. We take the args and pass them to Java, hoping for the best, fingers crossed. Fortunately, it worked. To reliably map the network drive, on startup we'll always remap it, remove the mapping, and then remap. Those magic arguments will be used forever. With the right choices in the exported XML schedule task, we'll never have to worry about drive mapping again, at least for this VM. Oh, I forgot to mention, we are creating a startup script here that will be run at startup, not actually mapping the drive at Vagrant runtime. Here, we map the drive. We also list out the files to verify we have indeed mapped the drive. Otherwise, we can't get the app. Some minor refactoring here to help the devs. We hint at the format of credentials. All of these steps have been to support eventual automation, which means we need to run things headless. We try a brief foray into Linux with XVFB, a virtual display frame buffer. Without headless, the automation test would always need to run on a user's machine. Here, we set up the scheduled task to start up the app on VM startup, like kiosk mode. The rest of the script, where Windows launches the app when we remote in. And the transform. At this point, OS provisioning is complete. With the app launching on startup, we can test with Sakuli. Our first test is to take a screenshot, since that will prove XVFB can see something, and that Sakuli can run with our installed version of Java. JRuby is used here, I think because executing Sikuli IDE eats a version of JRuby.jar that resides next to it. In a future slide, we'll install JRuby from scratch and use Sakuli solely from code. Note that we are again creating the script that will launch on startup, not actually executing the script. Remoting should launch the app and take a screenshot. Later, we have the app launch on connect, not just at startup. The JRuby used here is somehow available already. The relevant .rb files will now be covered. To take a screenshot, we use native Java imaging library and Sakuli's capture method to save an image of the screen. We use an instance of Sakuli's screen and region objects to get our bounding box, capture that, and write the bytes to a file. We also fix a bug in this commit where we forgot to add a quit command to .ed. The RB script just invokes our screenshoot module to send the capture message specifying a file name. We are finally at JRuby, the text approach. We can diff tests as text and organize a software architecture around a programming language. Here we install JRuby from the internet and specify Java home environment variable. The script to install JRuby continued, setting the path after we find the latest JRuby installation directory. As before, .ed files to transform the Vagrant file with a script to execute, and the JRuby setup and verification steps. This commit lets java.exe pass through Windows Firewall. We also need to fix an issue where the app starts up only the second time and subsequent times, and never the first. Here is the script to allow Java through the firewall and the transform to specify it to run. We're starting to develop a workflow. We'll use Sikuli IDE to manage images, the VM and JRuby to run tests, and Xfree RDP to remote in and take screenshots of UI components. Sakuli wraps OpenCV, which uses Tesseract, which needs Visual C++ redistributable, so we install that. Here is the scheduled task to run on login, which can launch the app, run tests, or anything needed. Continuing from previous, we copy to a common startup folder. Subsequent runs will trigger from a scheduled task. We use both methods to get the desired kiosk behavior, where the app always launches. Sikuli IDE will render screenshots as images, but they are stored as text. Ruby lets us use strings as expressions, so we can have a kind of hierarchy where child UI elements are beneath a parent string. The indentation is just a visual convention. As we are still in proof of concept phase, much of the code is procedural. We have very minimal boilerplate, however, just importing Java, specifying a path for .jars to Sakuli X import statements, and setting verbose debugging. After that, we minimize the JRuby window and get to automation. First, we tell Sakuli about our global app path, and then we sleep. Now we can start clicking and typing things. From this mess, we can break out the code into modules, classes, and concerns. From there, we can start to incorporate tests. We start and stop screen recording as a test, and then run config pos.rb. This batch script will run on login. We start to break out environment and config code into its own module. We want this repo to potentially host screenshots of different apps to automate, but they all live under a common bundle path. Same deal here, but two transforms. One to install Visual C++ redistributable, and the other to schedule a startup task. We take a breather and try something different, screen recording. Now that we have automation in place, we can try to see if a video can be recorded. First, we'll install VLC. Here's the invocation to start and stop screen recording. The latter is done with ncat. A lot of options are passed to VLC. From the ED file and the exe, it looks like we bundle VLC in the repo. That saves a download. VLC turned out to be too laggy for headless recording, and XVFB renders swing buttons in a strange way, so we need to look for alternatives. That's future work. For this commit, we fix the app not launching the first time. We reuse our existing script in the startup folder. The bits admin changes here supposedly make the JRuby download faster, but we replace it later with a much faster alternative. In the screenshot below, we copy a script to the startup folder. But it takes forever for bits admin to get its magic going, so we directly HTTP get the thing. Otherwise, downloading Java and JRuby files can time out. Here, we change out Java 11 for Java 8, and also use PowerShell's invoke web request to fetch faster. The Java downgrade is due to Ruby Maven Gem not yet supporting the newer version. Sakuli still works, so no big deal. Same here. We simplify from a polling bits admin to just HTTP fetching JRuby directly. Evidently, from Java 8 to Java 11, the dash version was updated to the more conformant dash version flag syntax. Okay, now we can address gems. That means bundler, as well as our internal config tool and linter. Once this project graduates to have additional contributors, we'll need a consistent coding style and use existing conventions. Here's what the gem file looks like. Of course, a script driven by an ed transform in order to get gems installed. And the transform itself. By now it should be very familiar. Now that we have a Windows VM and a running app that we can interact with using JRuby and Sakuli, we can start writing tests. Minitest comes with Ruby, so we'll use that. We install diff utils, although for code diffs I used Visual Studio Code from the local machine before making commits. We add the Minitest gem in the gem file, and a minor nitpick to use a no spaces install directory for VLC, and a bit of research to tell VLC to use a new install directory. And here's the .ed script to set up the install. Next, we'll refactor to modules and tests. With the proof of concept working, we start modularizing into components. The tests are UI-centered, and much like test automation in the web world with Selenium, we'll abstract interactions with Swing from user intent with the page object pattern. Here I'm just updating docs for dev startup and setting a Ruby opt environment variable for Minitest. And a minor refactoring here to more reliably select defaults in the point-of-sale launcher dialog. We split Sakuli API setup and a helper module. The boilerplate from the proof of concept to initialize Sakuli is moved into a Sakuli env.rb file, and the helper responds to the minimize window message. In Sakuli test environment.rb, we import useful Sakuli libs like debug, setting debug level, and introduce classes and methods to help with initializing the screenshot images path. This is where we store pictures of buttons, which in web tests like Selenium would define DOM elements through XPath. Here, we specify that the images representing point-of-sale UI elements like buttons, dialogues, etc. belong in a path off of the global image root path. The star.sakuli folder becomes a subtype, a specialization of a common parent class, which represents the parent folder. We also see the components class, which will represent the generic parent of UI components. Some private methods here to help with the methods in the previous slide. And we see the POS components subclass near the bottom, a specialization of components. In Ruby, the ease of thinking so fluidly of object hierarchies with the less than operator helps realize the idea of object specialization to provide specific behavior. More of POS components class in the next slide. With all the setup code from before, POS components just inherits from components, and its constructor is just to specify POS app. That's all the child needs to do is delegate to the parent once the type, POS app, is known. It's kind of hard coding, but seems okay since we're setting up a known environment. Introducing Minitest. We want to test our setup code and learn Minitest. Despite these tests, a bug will be fixed later, but hey, we're in a Windows VM from Mac OS running JRuby and Sakuli. The next bit is to connect that with testing the actual application. We introduce a spechelper.rb as well, which imports the needed libs. This assumes JRuby is invoked with a library path. Here's a checkpoint commit. These are fun. When you are grasping for the next set of features and end up roping in a bunch of changes you later need to summarize, it's nebulous in work like this, and I'm happy it just turned out to be a linear sequence of added lines. GitHub showing just addition after addition rather than switching between changes. Trial and error. We're adding to our image repository now. That is, our UI elements repository with more screenshots. We're getting closer to login and the data setup needed. Here we have configuration starting to be stored in a YAML file. Derived values are determined at the top, like use the specified default if not specified from environment. We also see a new module, Sikuli component, which itself has a component class, and this accepts the hash from Sikuli test environment : POS component. We're logging in now. Since we automated the mapping between image name and image path, the key is now the same as an XPath in Selenium, and we're navigating a quote-unquote DOM tree, except instead of a web page, it's the desktop. And we assert the image, the UI component, is present somewhere on it. Here's the bug fix where I was off by a directory level. It wasn't to /app, but the base bundle path itself. That seemed to create a redundancy in classes, but I might have let it be. Now we're starting on the road to automating the app. The setup we saw in Minitest is realized in the before do block. This turns out to be costly, starting up the app for each single test, but it's progress. Here, we see the change to use /app after all. Maybe the bug fix previously was to generalize the library as we are closer to runtime state, and the test would know more about initialization than the library. We bulk up spechelper.rb with our in-house config YAML parser too. We had a requirement early on not to use Cucumber, but the inspiration of the design of the classes mirror an organization toward natural language. We do not end up needing the Sakuli feature module, as feature classes can be inherited from Minitest. A minor refactoring here so that named components do not have to initialize themselves, but defer to the parent. Now we're just left with intent calls, simply named, and possibly various private helper methods. Now that we can log in, we can start automation on a basic workflow in point of sale. Here's the Sakuli feature module that we use Minitest's feature inheritance for instead. Here, we are just starting out on the boilerplate for the initial test. Here is a test where we want to try clicking all the buttons and ensure they act as expected. The difference here is to log out from the main window instead of from a dialog. Updating our spechelper.rb to include the unused feature module. Second interlude. There are some pull requests that never got merged. Those are from trying out Dubray's state actor model SAM pattern, but I kept getting Stack Overflow in my state machines. Getting a Ruby version of his rocket launch example is a definite to-do for me, but here we just start adding tests. The framework is set up now for us to add lots of tests. Some notes to self in the form of a README, how to exit from java.exe, removing the screenshot function as well, since by this point, the app launches reliably enough to debug other things. One more stab at VLC, but there are some quirks. The XVFB shows the UI with exaggerated swing buttons, so the screen caps we took of the components are not recognized. We end up having to hack around that, and headless is tabled for the future. If anything, by this point, we're pretty much writing page objects like in Selenium. Reused constants, what would be XPaths, are image names. In this example, checkbox no devices constant is used more than once, so we dry it out and add it up top. Here's the proof of concept code. The messy stuff we had before has been moved into components and methods. Here, we use runtime exceptions as pre and post conditions. Having methods fail fast is something I brought into my Selenium web testing. As those assertions live in the methods as contracts, we find the specs don't always have to check for them. In Cucumber, the then steps can be shorter and reflect user capability instead of specific UI elements. Borrowing from Node.js, we use an index.rb file to define the UI components that are themselves separate classes. Did y'all know a separate file that specifies an existing module automatically gets included for namespace purposes? That's nifty and keeps each file smaller. We have a process in point of sale called a take, and the UI elements reused are defined as constants. Each public method uses the primitives we have built up or borrowed from Sakuli, including click, type, wait for, and click find. Private methods for tracking state, like line item count, are managed through messages like increment line item count. The page object is take order. The interface reflects intent, like adding and accepting, and the consumer never directly clicks or types anything. Here are some more public methods from take order in service to tests and expectations. Continuing with the methods to use in tests before we look at the private methods. We just have only a couple private methods to track line item count state. Another component for the top bar UI as well, just for logging out. We just click the logout button, which to Sakuli is the image of the logout button. Once recognized, it sends a click. Here are the helper methods used in components defined in sakulicomponent.rb. Here's a simpler component, at least to flesh out one of the dialogues. I remember this dialogue has several more buttons. Oh, and the screenshot capability gets moved into a helper method. Thanks to Ruby's ability to execute shell commands, we can also encapsulate screen recording controls into the sakulihelper.rb module. In sakulitestenvironment.rb, we also add logging. And some more bug fixes. We also see the uppercase I lib flag, so our require statements don't need to all be relative. In future work, it would be nice to provide a Rails dashboard that could adjust on login.batch to run one or more tests. In Minitest, there is not a before all, but the internet had a solution. Just call them before the before do block. We see the initial steps to start up the app are pretty expensive, so we only want to log in once. Then every test per scenario can be done in an authenticated context. And here I'm refactoring placeholder code with actions. And here I'm adding more tests. So now we're starting to see the benefits of the interface. The tests nearly read like stepdefs. And finally, adjustments to the spec helper to include those new components. With that, we have successfully shown a Windows VM running our Java Swing app, integrated JRuby with Sakuli, and used Minitest to verify behavior. Not a bad run with free and open source software. Thank you.